NASA threw a $327 million probe straight into the surface of Mars. Not because the rocket blew up, not because of some freak accident in deep space, because two teams of brilliant engineers built one spacecraft and one team did the math in American units while the other did it in metric. And nobody checked. But here is the part nobody tells you. This was not one big mistake. It was a tiny mistake, made over and over for 9 months. And a human being noticed it and was ignored. The spacecraft was the Mars Climate Orbiter. Its job was simple and kind of beautiful. Circle Mars, study its weather, its thin air, its seasons. A weather satellite for another planet. It launched in late 1998 on top of a Delta rocket, and then it spent the next 9 months coasting through the dark toward Mars. Now, a spacecraft in deep space does not just glide in a perfect line, it drifts. Sunlight pushes on it. So, to stay pointed the right way, it fires little thrusters now and then, tiny nudges. The engineers called it angular momentum desaturation. And every time the spacecraft nudged itself, the ground software wrote down how hard it had pushed, so the navigators back on Earth could keep an exact model of where the spacecraft really was. And right there, in that one little bookkeeping file, lived the bug. The software that recorded those thruster pushes was written by Lockheed Martin, the company that built the spacecraft. It reported the force in pounds, American units. But the navigation software back at JPL, NASA's lab, read those exact same numbers and assumed they were in newtons, metric units. A pound of force is about 4.5 newtons. So every single thruster nudge was being undercounted by a factor of 4.5. The navigators thought the spacecraft was being pushed gently. In reality, it was being pushed 4.5 times harder than their math believed. One nudge and the error is invisible. But this happened again and again for 9 months across hundreds of millions of miles. The tiny errors stacked up. The spacecraft was slowly, silently sliding off course, and the model on Earth had no idea. Now here is the human part. The navigation team noticed something was off. The numbers were not lining up. They raised it. They wanted to fire one more correction, a burn to fix the trajectory. But their concern was not filed through the right channels, in the right format, with the right paperwork. So it got waved away. The correction was never made. On September 23, 1999, the orbiter reached Mars and lit its engine to slip into orbit. It was supposed to pass about 226 kilometers above the surface. Instead, after 9 months of stacking errors, it came in at 57. The lowest it could possibly survive was 80. It dipped into the atmosphere too low and too fast, and it was torn apart. NASA never heard from it again. And the lesson hits harder than just use metric. Edward Weiler, NASA's science chief, said it best. The problem was not the error. The problem was the failure to catch the error. Two teams spoke two different languages, and nobody built the one thing that would have translated between them. The bug was never really the units. The bug was the silence between two groups who each just assumed the other was speaking the same way they were. And if you got something out of this, send one signal back. Like and subscribe. Unlike Mars Climate Orbiter, I promise to read it in the right units. See you in the next one.